So when we're done with this lesson, I hope to be able to answer three things. How do mixtures and substances differ? Why are some mixtures classified as homogeneous, while others are classified as heterogeneous? And what are several techniques used to separate mixtures? So we'll be introducing a whole lot of new vocabulary dealing with mixtures and those processes we use to separate different components of those mixtures, and then also a review word, substance. So let's first talk about the review word, substance. Substance is another word often used for matter, and matter is anything that takes up space and has mass. So that would also include air. Air also takes up volume. It would take up the volume in a balloon if you were to blow into a balloon. And if you drop that balloon, it would go toward the ground because gravity's pulling it. So it must have mass as well. So a lot of people try to think of air as not being matter, but it is. And then the types of things that are not considered a substance or matter are those things that are energy, like light, anything along the electromagnetic waves. So talking about radio waves, sound waves, heat, things like that. Those are not considered matter. And before we get into mixtures, let me talk a little bit about pure substances and to compare those to mixtures. Pure substances are things that cannot be broken down by normal physical means. So two classifications for pure substances could either be element, or it could be, so anything on the periodic table, the definition of that would be things made of only one kind of atom, or it could be compound. Compounds are things made of two or more elements, and then they are chemically combined, cannot be separated by physical means. They're usually in a fixed ratio, and they have properties that are different from the things that they are made up of. And that's going to be the another real big difference between the pure substances and the mixtures. So let's talk about mixtures, which is what we're here to talk about today. A mixture is a combination of two or more substances in which each pure substance retains its individual chemical properties. So think of examples. Sure, let's take salt water. Salt, that's in salt water. Does the salt water still taste salty? Yes. If I was to boil the salt water, that would be, again, that'd be a physical change, not a chemical change. Would I get salt and water back? Yeah, definitely. So they never chemically combined. And then what about the water? Did it still maintain its properties? Yeah, it's still a liquid, and I can still evaporate it and at a certain boiling point. And yeah, I do realize that changed the boiling point slightly by adding salt to it, but I still can, when it evaporates, it's water vapor. It's not something different. I didn't chemically combine it, and I can use ordinary physical means to separate them. And then we're homogeneous mixtures. So there's two classifications of mixtures, homogeneous and heterogeneous. The homogeneous mixture is a mixture when the composition is constant throughout, or I like to say evenly distributed. Homogeneous mixtures, all of them can be called solutions. Those two words can be like synonymous with each other. So you think anything dissolved in anything. It's not just like salt water where it's a solid dissolved in a liquid. It could also be a solid dissolved in another solid, like any of your alloys where you have two different metals that have been melted, not chemically, not a chemical change, but they've been melted, a physical change, melted together and form a combination one metal dissolved in the other, so to speak. And then you also got gases dissolved in liquids. So think of your soda water. It's got carbonation, that carbon monoxide or carbon dioxide dissolved in that liquid. And then you also have gases dissolved in gases. So our atmosphere is a mixture of air molecules and stuff. So you can think of that as a mixture, not necessarily a solution, because they're not dissolved in one another. But that brings us to heterogeneous mixtures. It's a mixture where individual substances remain distinct from each other. So I like to say unevenly distributed. So you can think of things like salads and pizza, because it's got all these toppings and stuff, but those are easily picked out and distinguishable from the rest of it. It's not something dissolved in something. There's two types of heterogeneous mixtures that I like to mention here. There's colloids, and then there is also your suspension mixtures. Suspension has particles that are too big to settle out. I mean, they're so big that they do settle out. So think of like a mud puddle. You stop stirring it around, all that clay starts to settle out to the bottom. Or think of, for the other example, colloids. You could think of particles that do not settle out. So things like fog, all the little particles there, they rise with the heat and they don't settle out. Or fog. Both of these exhibit a special effect, so you can use this to say, oh, that is a colloid. They exhibit the Tyndall effect, which when you shine light at it, it scatters the light. So that's why you don't want to have your high beams in a fog or when there's smoke that's really thick, because it's just going to be a blind spot in front of you. You use your low beams instead. One last question that I asked when pertaining to this was, well, where does milk in all of this? Is it pure substance? Is it a mixture? Is it homogeneous, heterogeneous? And it's tempting to think that it's homogeneous because it seems to be consistent throughout, but that's because it's been homogenized, meaning they've mixed it so well in additives and stuff that it's made to look like it's homogeneous throughout, but really it's a bunch of fat molecules suspended in this liquid, and so it's actually heterogeneous mixture. And there are some more examples, like for instance, a gas dissolved in gas. Air in the scuba tank is primarily a mixture of nitrogen and oxygen and argon gases. So those are all mixed together in a solution. You have the gas and the liquid. I mentioned like with soda waters, liquid and gas, and then liquid and liquid. Solid, liquid, and solid, solid. So there's all kinds of different solutions. And then lastly, I'd like to talk about these three different types of ways to separate, methods of separating out mixtures. You're using those properties, physical properties, not chemical, you're using those physical properties to help separate out the individual things that are in a mixture. So you could use filtration, like if some of the particles that are in your mixture are bigger than other parts of it, then you use filtration and filter that out. Or for instance, the water molecules are fairly small; they'll pass through a filter. But if you're talking about mud or something like that, the mud, the dirt, that will stay behind in the filter while the water goes through. So that's a method of taking the solid from a liquid in a heterogeneous mixture. Distillation is a technique you use to really to use the boiling point to help separate things out. And so you let part of it boil off and then the other part remains because it has an even higher boiling point. So you think of salt water. If you want to get just the water out and leave the salt behind, then you could use its boiling point, because salt has a much higher boiling point, so it's easier to boil out the water and then the salt's left behind. If you wanted to collect and keep that water, you could cool and condense it on the other end and let it be separate. Crystallization is the last technique I'd like to bring up. There's lots more other techniques, but crystallization is a separation technique for homogeneous mixtures that results in the formation of a pure solid particle from solution containing the dissolved substance. So in other words, it will turn to crystal, and all the rest of the stuff either evaporates or is left behind. There's sublimation, so you can just let it go ahead, and it's like evaporating off, so it's a lot like distillation. And then there's chromatography, another one that I'd like to do a lab on, where so you could take like a piece of filter paper and make a mark about a centimeter above the bottom of that filter strip with some kind of marker, and then dip just the very edge of that into water, and then as the water wicks up or moves up there, it's going to carry pigments from that marker on up, and those pigments are going to separate out. So that's chromatography. Okay, so think about, were we able to answer those questions, and make that a comment on your notes. Thank you.